Let's look at those color maps we're trying to emulate again. You can see that we have successfully created this single hue progression from one color to another, but there's also the diverging schemes that are actually two of these concatenated together. And so that's going to take a little bit more work. The next complication in this is there's a few ways that we could make these color maps. We've already made the very simple one that is going from one point in the color scheme to another and just simply interpolating, but we could do it another way with a different number of arguments to the function that says I want to vary from one point to another, but I want to specify how many data points we're going to have along the way. Or I might want to specify a midpoint so that you interpolate once from the beginning to the middle, and then in a different manner go from the middle to the end. Finally, we could do that midpoint with specifying a number of data points along the way. Those are the four ways that I expect we could call this function, and that means we need to be able to have a function that deals with variable number of arguments in. To deal with all these different cases, I need to just put my input list as var arg in, which means variable arguments in. Let's look at where we parse these inputs. The first case is where we have nargin equals 2. If that's the case, we're going to assume that we've been given a start, we've been given an end, and that we're going to just have no middle, and that we're going to use the default num for the number of data points on the color map. The other case that is easy to call for is if we have the number of arguments in being 4, meaning we fully specified this problem, and then we can just hand these out varg in to start, middle, end, and num. Those are the two easy cases. What happens if we give number of arguments in equals 3? In that case, our varg in could be two different things. We could be handing in 3 colors, or we could be handing in 2 colors and 1 number for the number of steps on the color map. Well, let's look at the third argument because that's the one that's going to vary between these. If the number of elements in the third argument is 3, that means it's a color, and we can deal with that appropriately just using the default number for the number of steps. However, if the third argument has only 1 element, that must mean it's a number, and we're going to put a null for the middle of the color map. Finally, if neither of these cases works out, we're just going to throw an error with a default error message. And if none of those cases above were hit, then we're just going to throw an error message. And I've defined one error message so I can use it a couple of places. I don't like to copy and paste if I don't have to. And if I decide I want a different error message later, it's easy to change because I've defined error message right up here at the top along with default num for the number of steps in the color map. Once we get out of this if-then statement in line 32, we should be rest assured that we have a color.start, color.middle, color.end, and color.num. So we can just carry on knowing that we securely have these items and they've been checked. The one problem that might occur is if someone gives a num of 1, that is where the color map is only going to be 1 long. In that case, we better throw an error message also. You can see here that I'm going to be making use of interp_map, which is the code that we had just developed very quickly before with the linspace. And if there is no middle point, then it's going to be very easy. You can see that we just call interp_map with the start, end, and the number, and we're done. However, if the midpoint is defined, then we've got to do something a little bit different. You can see that we're going to call interp_map twice. twice, once going from start to middle, specifying the top number of points in that color map, and then we're going to call it again going from the middle to the end, looking at the bottom number of points in the color map. It's actually somewhat tricky how we define the number of data points in the top and the bottom, and let's see why. If we were specifying one of these diverging progressions from blue to gray, and we set our n equal to 8, you can see that the top color map here would get 4 data points, and the bottom point and the bottom side would get 4 also, but where do you put the specified middle? So that can be a little bit tricky. What if there was going to be 7 instead of 8? Then you've got another little tricky bit of math to do here. So the way that I figured this out was in cell mode inside of MATLAB. Let's take a look at how I did this. I knew I wanted my algorithm to be able to take n and decide how many points in the color map on top and how many on bottom. So I would say something like top n is equal to n divided by 2, and then bottom n is equal to n divided by 2. And let's just say n equals, as a question here, top n plus bottom n. And if I run this, I'll be able to tell very quickly if I've done this correctly. I want to look at all these results, so I'm going to concatenate them real quick. N, top n, bottom n, and flag. I will define this as flag. So let's run this. And I can see if I give an input of 22, I'll get an 11 map, and these do add up correctly. Great. Now I want to iterate through different numbers here. So I'm going to select that N22 and hit plus 1. But now I see a problem here, that if I have an odd number, it seems to mess up. So what are we going to do about this? Maybe my algorithm isn't quite right. I'm going to have to put maybe a ceiling on this and a floor here. Let's run this again. So it adds up. It adds up. Okay, that looks like the algorithm that we're going to need. Great. So now we're in a good situation. We'll be able to call this interp map with the proper number of data points for the top and the bottom and simply concatenate them. But there's one final problem. If we do this, then there's going to be a middle point that is the same, because you're using the middle twice and we don't want that. So what we're going to need to do is add 1 to the color map on the top or the bottom, and then when we concatenate these, we're just going to chop the bottom row off of the top color map and when we concatenate them, and that should work. To do that, I'm just going to go down to our code that we wrote that specifies the size of the partial maps and add 1 to whatever we're going to get, because we're just going to subtract it off at the end here. With that, I think we're ready to start testing. To test, what I'm going to do is take our specification here. I'm going to put peaks as our data set. And then after this, I'm just going to say color map A. And turn on the color bar so we can look at it. Let's run this. And we can see that we get a nice color map going from blue to white to red. What happens if we take this, put it in here instead, bring that down there so we don't lose it. Let's run this now. And we can see that we're nicely going from red to blue without the intermediate step. So that input worked. Let's grab this, which is going to be specifying the middle, beginning, and end without an n for the number of points. That looks good. And finally, let's run this one, where we're just specifying the beginning and the end. Very good. The final test is, let's make sure that when we do this, if someone puts a degenerate color map in here that has only like 4 points, what's that going to look like? It's a little bit blotchy, but it is giving the correct results. 3. 3 looks good also. 2. Well, we're no longer getting the white point, but what are you going to do if you've only got 2 points in your color map and you specified 3? So I think this is a reasonable thing to do. And finally, what if some joker puts in a color map of only 1? And we can see that we specify make color map for the correct input arguments. So now it looks like all we need to do is document this function, and we're done. So if we come up here, what are we going to do? The help always goes at the beginning. So make color map makes smoothly varying color maps, and so on. So that's how I would go through and document this. There's no need to watch me do that. Okay, well, I hope this was useful to you. It should show you a good way of going through and developing an algorithm inside of MATLAB. Thank you.